feel very, very lucky and fortunate to be here again and seeing some very familiar faces and some new faces. So as Bryant mentioned, I'm a naturopath, I'm a practitioner. So really when I'm sharing information, I suppose I'm really coming from that perspective. So I'm not a researcher, I'm not a farmer. And my day job is really just talking to people from all different backgrounds, with all different challenges, all over the country, which I'm very fortunate to do. But what I'm going to be talking about today and tomorrow is really more of a passion. So I've been lucky enough, I suppose, to be exposed to people who are farming differently and farming in a way which is obviously working with nature. And so it makes complete sense that I'm coming from the same philosophical perspective with human health. But it's really the nexus between farming practices and human health outcomes that I'm especially fascinated by. So that said, I'm not an expert. I definitely wouldn't say that I am, but I'm really excited to learn this weekend from so many other people, but also share a little bit of what I've learnt. And also sort of, you know, what we don't know. So actually this talk is sort of, I suppose, just acknowledging the concept with nutrition and human health that there's still a lot that we don't know. And this is this concept around nutritional dark matter. So has anyone read any of Adam Grant's work? So he's an organisational psychologist. This quote is from a book of his called Think Again. And he says, "Knowledge is power, then knowing what we don't know is wisdom." And I feel like I'm gaining a lot less knowledge the more that I learn, and more wisdom. And the concept or the topic around nutritional dark matter is definitely brought a lot of wisdom to me, so hopefully it does with you as well. So I wanted to start by really, I suppose, just reflecting on where we've come from in the past sort of 100 to 150 years, I suppose, in an understanding around nutrition. And I think it's important because when we look back, it sort of sets the scene, I think, for how much things are likely to change, I think, in the way that we talk about nutrition, the way that we study nutrition, the way that we study human health. I think basically with AI, with technology, with metabolomics, with microbiome testing, with being able to measure for both human health and food the previously immeasurable. So whether we're talking about genes, whether we're talking about microbes, whether we're talking about phytochemicals or the chemical makeup of food, none of this has been previously sort of trackable. Like, we've known it's there, very hard to sort of look at it right. Whereas from here moving forward, honestly, this is just going to explode, I think. So I think our sort of even our terminology around nutrition is likely to change moving forward. So if we come back here, right back through to, I suppose, one of the first discoveries that nutrients affected human health outcomes. So that was probably the most famous example was James Lind. So he was a British naval surgeon who, you know, discovered that citrus cured this horrible disease called scurvy. But even then they knew that there was something in citrus and sauerkraut that actually helped these sailors, but they didn't know what. And it wasn't until about 200 years later, actually, that they discovered, oh, it's this thing called ascorbic acid or vitamin C. And so just because they didn't have a tangible name to that, they still went ahead and gave people citrus. And, you know, so I think sometimes in nutrition as well, we feel like we've got to know it all before we act, and we just don't. Like, you know, we didn't have to wait 200 years to name vitamin C before we started giving people citrus fruit, for example. So, you know, in terms of, I think, moving forward, in the 19th century, this is when a lot of our key phytochemicals were discovered. So today I'm really going to be talking a lot about phytochemicals. So phyto meaning plant, chemicals meaning chemicals. So some of the main ones, morphine, codeine, nicotine, caffeine, so the world's most widely consumed drug, caffeine, these are all discovered in the 19th century. We still use them a lot today. Early in the 1900s, there was this biochemist by the name of Casimir Funk, and he pioneered the concept of vital amines. So basically he discovered, it was a bit like James Lind, and he discovered that, okay, there was these people that were getting pellagra and beriberi, which were deficiencies of B3 and B1. They were getting very sick, and they established that, okay, these are what they called vital amines. This was the genesis of what we now call vitamins. And so that really wasn't that long ago when you think about it. And then in the 1930s, this was the Great Depression era, and this is when basically the RDIs were developed. And so the main takeaway here is that we still use some of the RDIs now today that were established 100 years ago. So for example, the RDI for B3, we still use that same RDI now. But the goal in the 1930s, in the Great Depression era, was simply to keep people alive. We didn't have the obesity epidemics, the overnutrition that we have now. So when we look at sort of, I suppose, food and we learn about, even from a conventional perspective, we're still taught as long as people are meeting the RDIs, they're doing okay. The RDIs don't really apply in this day and age with the nutritional challenges that we have. The RDI for vitamin C will prevent scurvy, but will it do all the other myriad of things that vitamin C does for us if we bring it up even further, for example? So it's just good to think about, I suppose, the genesis of these terms that we always hear about, right? And then in the mid-1900s, there was a bit more of a focus on minerals. So we started to learn more about calcium deficiency and bone disorders, or iodine deficiency and goiter, for example. So these were studied more. Moving forward in the sort of late 1900s, we started to learn about zinc and selenium, for example. So zinc, I think, was first sort of named and really studied in like 1963 or something. So these are relatively new kids on the block, really. And we're still unpacking a whole lot about how these nutrients actually work in the body. And then in the late 1900s, there was a sort of broader recognition that food contains more than just vitamins and minerals and fatty acids and proteins and carbohydrates. Food contains antioxidants. And we thought back then, or it was thought back then, that there was maybe like a dozen, maybe a couple of hundred of antioxidants in food. But then moving forward now, we've got the technology to say, holy moly, there is so much more in this food than what we previously realised and had previously been able to measure. And that's really what I'm going to be talking about today, is this nutritional dark matter. I've got a clicker, I keep forgetting about that. So what I want you to take away from this is that when we've largely sort of been talking about and learning about nutrition, we've been learning about the lipids, the sort of fatty acids, proteins, carbs, vitamins and minerals. And today I'm talking a lot about the secondary metabolites. That doesn't mean the rest obviously isn't important, but that's got the lion's share of attention, for us. Whereas if we think about what these things are doing in a plant, so who sort of knows or could tell me a little bit about, because I'm not a soil scientist, but I know there's lots of amazing farmers here, what phytochemicals might do for a plant, for example? You don't have to be. Immunity. Exactly. So a plant will produce these as a defense mechanism, right, to help the immune system of that plant or the antioxidant potential of that plant to reduce sort of disease and pest pressure. For example, it'll increase beta-carotene in a pumpkin as a sunscreen so that the pumpkin doesn't get burnt. And so it's really about, not the building blocks of the plant, but it's about all the other important things for the health of the plant. And that's essentially where we're at with what these phytonutrients do for us from a human health perspective as well. Now, who's familiar with the work of John Kempf? So John Kempf is incredible in terms of being a thought leader in the regenerative agriculture space and soil science. And he said numerous times that if we are going to have a legitimate conversation about food as medicine, this is where the medicine lies, and he's referring to the phytochemicals in a plant. And I absolutely agree with that. So, when we've traditionally studied nutrition, we've taken a very reductionistic approach to it. So what I want you to take away from this is that when we eat food, we don't eat isolated nutrients, right? Like when we eat an egg, we're not eating just the amino acids in that egg, we're eating the food matrix. We don't eat food in isolation, we eat a matrix. And so some of the problem with a lot of our nutrition research is that it's come from that isolated perspective, right? So we've almost studied nutrition in a drug-like context, and that's problematic because that's not how food works. Food works as a matrix, not in isolated constituents. And that's not to say that what we've learned has not been very helpful, but it's not really how food works in the body. Food works through this sort of what I call entourage effect. And people that have studied herbal medicine know this, that plants work via many different mechanisms because of the matrix in that. It's not just the curcumin in turmeric. It's the entire plant, right, that gives us those benefits. And so this is really important to, I think, acknowledge. And the fact that we're now learning about this nutritional dark matter, which I'm going to talk more about in a minute, actually opens up the door for research to change in terms of how we study nutrition, which I think is really exciting and actually going to give us a lot more benefit potentially in terms of the outcomes of that moving forward. This is one study that I think is just absolutely nailed it. So in an effort to uncover the magic bullet, scientists inappropriately studied nutrients in a drug-like context. Unlike drugs, nutrients do not function in isolation and have beneficial effects on multiple systems, tissues and organ systems, and a narrow focus on a single or primary outcome measure is not practical and does not fit the nutritional context. And this is part of the reason why we're getting so much conflicting information around food, is because we're sort of looking at it as though it's in a drug-like context, like an isolated part of food, and that's just not how we are as humans and how we interact with food. So this term nutritional dark matter is actually borrowed from genetics. So some of you might be familiar that in the field of genetics, there was this, quite a while ago, there was all this talk about the fact that we had all this junk DNA. So about 98% of our DNA was put down to being what they call junk DNA because they actually didn't know what it was doing there and what it did. So it was called junk DNA. Now we know about 2/3 of that junk DNA actually is really, really bloody important and actually can code for different diseases and disease risk. And so we're sort of there in terms of how we, I suppose, think about this nutritional dark matter in food as well, in the sense that we don't really know all that it's doing for human health, especially. I think we have more solid understanding about what some of these plant-based chemicals are doing for the plant. But then in terms of how we interact with them, we're still just at the tip of the iceberg, I think, with unpacking that. But that doesn't mean it's not important. So we've got to be really careful not to just call it, junk nutritional dark matter, because we don't know what it does yet. Yeah, and history would show us that we have a very good way of, downplaying and dismissing things that are very important. So this is a study from last year that showed that when they looked into, say, for example, with garlic, but a whole range of different foods, they found 139,000 different molecules in food. So when we think back to even 20, 30 years ago, we were talking there was maybe hundreds or thousands in food. And then there was a study that was published in 2019 that showed that there was about 29,000 up to 30,000 different biochemical compounds in food. And now this one last year showed there was 139,000. And so you can see where we're headed. It wouldn't surprise me if in 5 years' time I come to something like this and someone amazing saying there's millions of these, of these phytochemicals or compounds in food. And again, I think with technology, it'll be really interesting. The speed at which we'll uncover this is actually really exciting. So for example, when they researched garlic, they showed that there was 150 known nutrients in garlic, so mappable nutrients that then we know what these are, we know what they do for us, but there was 135,231 unknown molecules and nutrients in garlic. With basil, for example, it was about a similar sort of ratio. So when we're looking at like a nutritional panel, or even some of the, more in-depth information about a food, the information that we get is usually between 150 and 200 different, nutrients that we'll get information on. So we'll get information on, for example, the amino acids in an egg. We'll get the information about the carbohydrates and the different types of sugars in there and the different types of vitamins and minerals. But we won't be getting information about all of these other things. So what do they actually do for us? Well, the thing about these phytonutrients is that because, like in a plant, they're not important necessarily for the structure of the plant. So, they're not necessarily about growth of the plant, for example, but that doesn't mean they're not important in so many other ways. So because of that, we don't have an RDI for any of these. So there's no recommended daily intake that we need to have for human health for phytochemicals like we do for vitamin C and scurvy, for example, which I think is a little bit problematic because that means they've been somewhat dismissed, that they don't really matter because we're not going to get unwell if we don't have them. And yet if we think about really what puts the medicine in a food, what puts the medicine, for example, in turmeric? It's not the carbohydrates, it's not the proteins or the fats, it's not necessarily the potassium levels or the magnesium levels, it's the curcumin and it's the other phytonutrients that are in that. And so I think, these are so incredibly important from a human health perspective. It's just unbelievable how important they are. So I'm going to sort of attempt to share a little bit about what we know in terms of what they do for us from a human health perspective. But again, keep in mind that we are just at the tip of the iceberg here. So one of the things that they do, so one of the biggest classes in terms of these sort of phytochemicals in plants is polyphenols. Who's heard of polyphenols? Yeah, they're getting lots of attention, which is great. So there's over 8,000 different types of polyphenols that have been identified in food. So they're one of the largest classes of phytonutrients. And they largely act as microbiome modulators. So if anyone had a green tea this morning, 90 to 95% of the polyphenols in the food that you eat that is rich in polyphenols or antioxidants, plant secondary metabolites, gets metabolized by your gut microbiome. So there's lots of experts that would say, actually, these aren't really like antioxidants. They're actually more prebiotics. They're actually, so there's been actually experts in the field that have said we need to rename these polyphenols less as being sort of like antioxidants in food, and we need to start calling them prebiotics because of the way in which they interact with our microbiome. And so what happens is, you eat food or drink food that's rich in these polyphenols, your microbes have a field day, and then they spit out a metabolite, we absorb that metabolite. So it's basically a win for your microbiome and then a win for you. So it's like an upcycling effect in the gut. And it makes perfect sense because this is like a mirror of what's happening in nature. So what adds those phytochemicals to food in the first place is basically good soil health and thriving microbial life in the soil. And so it makes sense that the microbes in the soil are putting these metabolites there in the first place, and these polyphenols, but our microbes are having an absolute field day because they're loving this. So it's really just a mirror of what's happening in nature in many ways. So those that have more polyphenols in their diet generally have better microbiomes in terms of more diverse and more robust microbiomes. Now, what else do we know? So one of the other things that these compounds do is they can act like thermogenic agents. And so we've all had this. So we've all had chili, for example, and we've felt it increase our heat, in our body. Ginger. There's foods that are cooling as well. And this again is largely because of these phytochemicals in food. We know that, yes, of course, they're antioxidants, but they're not just antioxidants. So when I was learning about these like 15 to 20 years ago, we were basically told what they do is they come and donate electrons, they scavenge free radicals, and that's how they reduce disease risk, by acting as antioxidants. And there is absolute truth to that, but that's sort of just a slice, of what they do. But absolutely, they can act as antioxidants in the body, which is incredibly important. We know pretty much the two universal drivers of chronic disease. One is chronic inflammation and the other is chronic oxidative stress. So basically, increased aging in the body. And so this is really important to slow down the rate of which aging occurs, essentially. Chronobiotic agents. And so it's really cool to think that these plant compounds are actually talking to our body clock as well. Who had coffee this morning? Only a third of you? No way! That's amazing. So that basically speaks to our melatonin, cortisol, adrenaline, all of these different hormones to say, okay, it's time to wake up now. Like, so they're chronobiotic agents, and caffeine is a phytochemical. There's also a compound in tart cherry, which is basically like a plant-based melatonin. So again, it can work in different ways, but we're getting information in terms of our body clock about these phytochemicals as well. Appetite regulation. So there's a saying in nutrition that quality reduces quantity. Has anyone heard of that? Yeah, and it's so true. I mean, we've all experienced this when we've had, for example, dark chocolate. Like Susie gave us some beautiful dark chocolate last night. I think it was about 90%, and it was really difficult to overeat. Now again, that's not because of the fats or carbs or protein in that. That's because of the phytochemicals. That's because of the cocoa, right, and the phytochemicals that brings. And so when we increase the quality of our diet, the handbrake goes on to overeating. Whereas if we all sat down to some milk chocolate, it's so easy to overeat because we don't have these phytochemicals that basically put the handbrake on overeating. And so this is one of the reasons why very rarely will I get clients to weigh their food. Very rarely. Like I'm talking twice in 15 years. Because I think if we naturally increase the quality of our diet, satiety will generally take care of itself. Again, really difficult, like we used to have this really punchy rocket that I'd have with breakfast every morning. It's really difficult to overeat that because of just how nutrient dense it is. It's really difficult to overeat lamb's liver because of just how nutrient dense it is. And so when, again, we're focusing on quality in our diet, I really think that quantity generally just takes care of itself. So this appetite regulating effect is largely because, not only, but largely because of the phytochemicals in food. Epigenetic modification as well. So I'm sure you're all familiar with the term epigenetics and the fact that how we live our lives, the environment we live in, the things that we do, the thoughts that we have, the food that we eat, can upregulate or downregulate the genes that we're dealt, basically. But food is a powerful manipulator of our epigenetics, and phytochemicals especially do this. So the guy that, very clever guy that came up with the term nutritional dark matter, he's actually a network scientist. He works at Harvard, Albert Laszlo Barbarossi, his name is, and he basically was studying network genetics. So he was looking at the interactions between different genes and how that determined or influenced disease risk. And so this is sort of, he was coming from sort of a systems-based perspective, which I love, and he really understands that it's the interactions between the parts that determines the outcome. It's not, it's the interaction between the gut and the brain that determines the outcome, not one or the other in isolation. And so he really came at this sort of understanding nutritional dark matter that way. But when he put food and dark matter alongside these interactions in these genes, oh my gosh, the influence on so many different genes in so many different networks was absolutely incredible. And if you look into his work, you can see all these beautiful images of how food is up-regulating and down-regulating our genes. So very powerful influencing factor. And again, I would argue this is largely because of phytochemicals in food. Hormonal influence. So we know that certain plants can have estrogen modulating effects. For example, so flaxseed has phytoestrogens in it. So we can get these hormonal modulations and manipulations through both plants, so herbal medicine, but also food as well. And hormesis. Who's heard of the term hormesis? I'm sure some of you have. Ben? Do you want to explain what it is?
It's essentially the balance between the body and how we take the nutrients, how we sustain.
Sort of. So it's got a few different applications, but basically what it can do is it's sort of like the upside of stress, but in relation to food, it's basically when food is like slightly stressing us out and that there's benefit that comes with that. But hormesis is really about the upside of stress. So we know, for example, that the bones that you put the most amount of stress on, healthy stress through weight-bearing exercise, are going to be the strongest bones. So that's a stressful event for the body, but it actually makes you stronger. And so hormesis can be applied in many different ways, cold therapy, sauna therapy. This is all via hormesis. But one of the really interesting ways that actually was, I think, originally a Fred Provenza article that came out was that one of the ways in which phytochemicals actually make us healthier is actually by slightly stressing us out, which is really interesting because when you eat a food that's rich in phytochemicals, you're basically getting this sort of little upregulation of immune factors and inflammatory factors, and then they sort of calm down again. But via doing that, you're basically making yourself stronger in terms of all of these different pathways that I've been talking about. I think it's a really interesting way to think about food, and the fact that it's sort of like Nicole Masters often talks about the fact that in a landscape, we want to tickle the system. Like we want to tickle the system to just slightly stress it out, but that makes it stronger over time. And these are what phytochemicals are doing, like they're tickling the system, which I think is really a very cool upside, to phytochemicals as well. And so when I went down this sort of rabbit hole of phytochemicals and what they're doing for us and what we know, I basically came to the conclusion that they're not just antioxidants, they're not just bioactive compounds, but they're basically messengers, modulators and facilitators and catalysts. And they're really helping us with balance. They're really helping to restore balance in the body. When you think about how so many of them worked that I just talked about, hormones, sleep-wake cycle, detoxification pathways, epigenetics, tickling the system, this is actually about balance in the body. And really, in some ways, the holy grail for human health is homeostasis, which is a state of balance. And I know when I'm looking through pathology or blood test results, what I'm looking at is like, how balanced is this person? How balanced is their sort of inflammatory markers versus their anti-inflammatory ones? How balanced are they in terms of their zinc and their copper, or their B vitamins or their iron, for example, with other nutrients? Like, what's the balance here? And this is really what phytochemicals are doing. Now, in terms of the impact of cooking and soaking and food combining and fermenting, these have really powerful influences on phytochemicals as well. Because some of these phytochemicals have been demonized, I suppose, lately. And that's because some people believe, and there are some phytochemicals, of course, that can be very dangerous for us, like the phytochemicals in death cap mushrooms. They're not great phytochemicals, right? There are so many different types of phytochemicals that we do need to be mindful of. The phytic acid family, oxalates, for example, that can be called anti-nutrients. But I think what we've done is sort of thrown the baby out with the bathwater a bit and said, oh, well, phytochemicals must be no good for us, therefore we're just going to reduce all of them. But actually that's just such a sort of almost a very reductionistic way to approach, I think, food. And this is where food culture comes in, and this is where our knowledge about food is so darn important. Because if we forget about how to prepare a food to reduce phytic acid, for example, then of course we're going to have more issues with that food. And so I'm really concerned about the loss of our food culture and our knowledge around cooking and preparation, because that impacts so much. So just as an example, the Italians have known for such a long time that when we cook tomatoes, especially in olive oil, it increases the absorption of lycopene in that. So lycopene is one of the major phytochemicals in tomatoes that reduces the risk of prostate cancer. So it does that by about 30%. And we've known this through food culture and information for a long time, right? We know that when you preserve a food or even add like herbs to foods and spices to food, it also impacts the way in which we mobilize or use those phytochemicals as well. So, for example, with salami or traditional pork recipes, you'll often see fennel in there. Now, the fennel acts a bit like a preserving agent, but what it also does is actually help with the digestibility of the phytochemicals, but also the richness of the food itself. So these traditional recipes aren't there by accident. Like, there's so much wisdom in that. And this is one of the reasons why I love using old recipes. And also fermenting can, either reduce or enhance phytochemical levels as well. So for example, oxalates are one of the class of phytochemicals that some of you might have heard of that have got a pretty bad rap lately. And if we get too many oxalates in the system, they can build up in our genitourinary tract, they can build up in our joints, and they can cause inflammation and pain, for example. However, we know that we have a microbe in our gut called Oxalobacter forminges. And Oxalobacter forminges basically eats oxalates before, like I was talking about, they go through the microbiome first. But we know that with the use of antibiotics, with the use of proton pump inhibitors that are often used for reflux, with basically the decimation of our microbiome, which I'm going to be talking a bit about tomorrow, there is a large part of the population that lacks Oxalobacter forminges, which means when they consume, say, beetroot that's rich in oxalates, for example, they're going to get more that comes through that hasn't been metabolized. So they're going to have a higher load of these oxalates. So when I hear people are having problems with some of these phytochemicals and oxalates, for example, then of course the first port of call is, how's your gut? Are you missing these microbes that are actually helping you metabolize this? So through fermentation, what we know is that if we make beetroot into beet kvass, which is the fermented drink version, that reduces the oxalates in that. So the fermentation process makes it more digestible and absorbable. We also know that it can increase some of our beneficial phytochemicals. So polyphenols, for example, are really high in tea, as I've mentioned. And when you ferment a tea and add sugar, what do you get? Kombucha, yes. And when you have kombucha, you're actually getting more polyphenols than the green tea or the black tea or the herbal tea itself. So it's increasing the polyphenols within that. So what cooking and fermentation, a lot of these traditional recipes are giving us is what they're doing is actually reducing a lot of the not so favourable phytochemicals and increasing a lot of the more favourable ones. Sourdough is another great example of this. Sourdough is a completely different product in so many ways nutritionally to a mass-produced tip-top white bread. And part of the reason is that because it's the processing of it. Of course, it's about the raw ingredient, but it's also about how that grain has been prepared, in terms of whether we benefit from it or not. So animals have dark matter as well, because of course, when they're consuming plants like Bryant's cattle are here, then they're getting an absolute smorgasbord of phytochemicals as well. And so we know that the more types of different plants, the more diversity an animal has, and this is true whether we're talking goats, sheep, chicken, cattle. When we increase the phytochemical diversity or forage diversity in their pasture, that's obviously going to come through, to their food. And you can taste this as well often, but what it does is, absolutely increase the dark matter, nutritional dark matter, and the phytochemical richness of that food as well. We're going to be talking a little bit more about the animal health and human health and these phytochemicals tomorrow, but just wanted to touch on that this is not just about plants. This is also about the plants that the animals are eating. So what about farming practices and phytochemicals? Well, obviously the health of the soil has a bloody huge role to play in how much medicine or how many of these phytochemicals are in a plant. But not only that, it also influences the type of phytochemicals that you have within a plant and the ratios and balances of those. Because of course we want more of the beneficials and not so much of the ones that can be not so good for us, like the phytic acids, for example. And when a plant has been grown in really, really healthy soil that is alive, then you're not only getting more phytochemicals in that plant, more dark matter, but they're better ratios for us as well, which is so very important. So in terms of some of the studies, so there's so many, and there's a book called What Your Food Ate by Anne Bickel and David Montgomery. Has anyone eaten? I could eat that book. Craig? Fantastic. Isn't it amazing? I actually genuinely feel like it should be compulsory reading for every eater. It is so, so good. And basically what Anne and David have done is look at about 1,000 or more different studies and collated that into what do we know about basically plant health, human health, animal health, and human health, and what is the evidence there, which I'm very, very grateful that they've done that. So some of these are from some of the findings that they found. They've also published their own study as well. But this one here is a big one. So analysed almost 350 peer-reviewed studies comparing organic and conventional, and they basically showed that, generally speaking, there is a higher phytochemical content in organic produce. So anywhere up to 60% more phytochemicals. Some studies will show that there's more like an 80% increase in phytochemicals. But not only that, you're also getting less of the heavy metals as well. So cadmium, for example, in unhealthy soil is quite an issue. And when you've got basically better soil health practices, it's not just about all the good stuff that's in there, it's also about reducing the things that aren't so good for us as well, like cadmium. Now, of course, we don't have a lot in terms of regen data, but I think it's still very useful to look at generally organic practices, and this is not just about, I suppose the benefits don't just come from soil health with not using chemicals, but also the impact of, say, phosphate fertilisers on nutrient density is huge, and nitrogen absolutely huge as well in terms of the impact on largely reducing phytochemicals in food. And so this one down the bottom I thought was really cool. So they found that agronomic practices could increase the content of beneficial phytochemicals tenfold in broccoli and double them in radishes, broccoli and cauliflower. That's massive. That's such a huge difference. I feel like this should be, on the front page of, well, we don't read newspapers these days, but I don't know, Facebook or whatever. But these are really big differences, that they're talking about. So I also recently, I'm sorry for this is a bit blurry, but recently came across this old Monsanto ad. So this was an ad from the 70s or the 80s that basically was trying to tell us that all things contain chemicals. And it's really that, what does this say here? You see, there really isn't much difference between foods made by Mother Nature and those made by man. What's artificial is the line that we draw between them. Interesting advertising though, right? We're all chemicals and, it's all good. It's just that we've decided that the orange is bad and the orange is good and the Monsanto, the Roundup's bad. When Bayer bought Monsanto in about 2016, they put aside $16 billion in lawsuit funding because they've basically said, we're sorry for marketing this in this way because we understand that we actually really damaged a lot of people, by doing this. But it was just so interesting to see that even then they were talking about phytochemicals. But in some ways, I worry that we haven't really learnt our lesson because this, for example, is basically the nutritional panel of a lab-grown meat or a cell-cultured meat, plant-based meat and grass-fed and finished ground beef. And this nutritional panel is almost identical. And so consumers would be led to believe that, well, these are nutritional equivalents, but the wonderful Stefan Van Vliet and his team actually then did a deep metabolomics research on plant-based meat and grass-fed beef. Said, okay, are they really all that match? When we look at the dark matter, when we look at all of those other tens or hundreds of thousands of different compounds in food, and basically what they found was that there was a 90% difference nutritionally in these two products, even though that nutrition label would have you believe they're 99% the same. There's actually a 90% difference. And so, I think in some ways in terms of the way in which we're marketed to, we haven't really learnt our lesson at all. Yeah. This is also some research from Fred Provenz's book. A passage from Fred Provenz's book, Nourishment, which I'm sure many of you have read. And he sort of talks about the fact that one of the principal pillars of nutritional wisdom in animals, so there's three. One of them is basically the presence of these phytochemicals, and that signifies to our body that, as I said, quality over quantity. Handbrake comes up, we've had enough now. So this is how animals manage, right? This is how they manage their appetite, this is how they self-medicate. And one of the things with ultra-processed foods that I don't think is spoken about very much, which sort of ties into the slide beforehand, is that it's not just what's added to ultra-processed foods that's problematic. It's not just that they've added emulsifiers and additives and preservatives and whatever. It's what's not in it. It's what's missing. It's the dark matter that's missing, that's putting a handbrake, you know, and it's actually our bodies sort of really looking for that from this nutritional wisdom perspective. And so I think a huge problem with ultra-processed foods is actually what they don't have. They're just so incredibly empty, like I shared with you about the beef example. And I actually spoke to Fred about this whole, when I went down this rabbit hole of nutritional dark matter, and I know I sort of was like, can we really map it? Really? And are we really going to get to the end here? Because, for example, the garlic that they measured that showed that we know this much about this garlic and we don't recognise all these compounds, the garlic that's grown probably in the UK where that study was done is going to be really different to the garlic that perhaps Susie grows here from a phytochemical perspective, because environmentally there's so many differences. So the plant has to change its immune defence, right? It's going to change the suite of phytochemicals. So it's a massive task to try to map dark matter, because I wonder if there's ever going to be an end point. And I asked Fred too, like, does nature ever get to a point where it's not going to produce any more phytochemicals? Again, can we really map it, you know, to the end? And this was his beautiful response. I think there's no end in the variation within themes of compounds that plants can produce. It takes so little effort or energy for plants to tweak basic structures and come up with a whole new compound. All the anatomical and physiological machinery is already in place. So my take from this is nature's probably going to be 10 steps ahead of us, as always. And I'm really okay with that. I really am. But I think what the dark matter research is probably showing us is that there is so much more to food, and we've really underestimated the complexity and intelligence of food, I think. But I don't know that we're ever going to get there, is my take, in terms of mapping all of this. And, you know, I think as well, one of the sort of, I suppose, the cautions that I have around us, and I love going down these rabbit holes, I love learning the science, but I think we're, you know, nature and even us and food is more than that. Like, we're stories, right? And if I die and someone just is like, she had great biochemistry, like, I'd be a bit offended, because I'm so much more than my biochemistry. Do you know what I mean? We're so much more than that. If we're judging everything on just the chemical makeup of something, we're missing so much of the conversation around health and food. You know, it's only one part of the equation. And this is why I think understanding that, you know, it's the stories around the food, it's the food culture, it's all of that. It's eating with each other. You know, that is so, it's just as medicinal, in my view, as the dark matter is, all these phytochemicals. So why does it matter? I think what this does, hopefully, and hopefully what I've been able to sort of pass across today, is that this gives us an insight into, a big insight into the role of farming practices on, you know, the quality of our food. And it broadens the conversation about what is food quality. You know, it's not just about what is nutrient density, right? It's not just about vitamins, minerals, fat, proteins. It's also this whole other suite. And what that will then do, I think, is inform food as medicine programs moving forward. This is already happening in the States, where instead of food as medicine programs coming from any old produce prescription, you know, giving someone a produce prescription saying, here's $100, you know, go to any place and get your fruits and veggies and your proteins, it's actually linking back to farms and saying, actually, we're going to start food as medicine programs like on the farm, because we know that this cauliflower is going to contain 10 times more sulforaphane, which we know is really medicinal, compared to this one over here. And I think dark matter and studying all of this will actually help in terms of, I think, just moving the needle in a better direction, you know, for this. I also read recently that in terms of our like drug development, it's something like 10 to 15 years maybe longer before a drug is actually on the market. And I should have my stats here, but it was in the billions. It was something like $10 billion, for like crazy amounts of money to get a drug on the market. And yet we know that food can interact with our genes. Food can reduce disease risk. I'm not saying there's not a role for that, but I am saying that this can happen a lot faster with a lot less cost and have a massive impact on human health outcomes. And so I think that's really exciting as well. And I think that's about it. Thank you so much for your time.